Alright, in this video we're going to find out if that given function is add, even, or neither. The main idea when you talk about even function is you always replace the negative x. But if you replace negative x into that given function and you still get that original function, therefore that function is going to be even and that graph is going to be symmetric about the y-axis there. If you replace negative x, but instead you get opposite of the original, then in that case, you're going to say that the function is add, and the graph is symmetric about the origin there. But what happens if both cases fail? Then there you're going to say neither. So let's start with example 1 here. The first thing that I'm going to do is replace negative x. So I'm going to replace it here since there is only one variable here. If you look at it, negative x to the second is basically x to the second. Don't forget that anytime when you're replacing a negative and the exponent is an even number, automatically you're going to end up getting positive. But also keep in mind, if there is a sign outside, you need to use it. And that sign don't have to do anything with what you get from the rule that I just gave you. So again, even power will give you always positive and odd power will give you always negative. So in this case, I got positive, but since the outside is positive, it stays positive. Now, if you look at it, what you're going to say is this our original function? Yes, it is. So you're going to say right there, is basically f of x. So clearly in this case, if you look at it, f of x equals, f of negative x equals to f of x. So this implies that the function here is even and the graph is symmetric about the y-axis there. And that's basically the end of that. Let's go now to the next one. And let's do the same thing here. You replace the negative x. In this case, you're going to replace it in this variable. And you're also going to replace it in that variable there. So that's how basically the example is going to look like. So now here, just like before, this is negative and this is add. So you're going to get negative. Since outside you saw positive, you have positive, it stays negative. This one, technically, the exponent is 1. So a negative and add will give you negative. But keep in mind that you have this minus outside. See, and this is what you need to be careful with. Even though in here you get negative because of the exponent, now you're going to multiply by the negative 2. Negative and negative will give you positive. Now what you're going to do is compare your answer with the original. Is this the original? No, it's not. So right there what you're going to say is this is not an even function here. What you're going to do immediately is you're going to factor out the negative sign. So if you factor the negative sign from here, this becomes positive x cubed, and this becomes minus 2x. And don't forget, when you factor out the negative sign, it's like you basically changing signs. That's what allows you. See, once you take out the negative, you just do the opposite on the inside. And now you're going to compare again with the original. X cubed minus 2x, is this the original now? Yes, it is. So in this case, what you're going to say is negative, and this is the original, so it's going to be negative f of x. So clearly in this case, if you look at it, when you replace negative x, you got the opposite of the original. And therefore, in this case, the function is going to be add, and the graph is going to be symmetric about the origin there. And that's basically the end of that. If you notice, I'm not writing the statement That's something that you need to find out when you're doing this. How is that they want you to set out the final answer? Um, and let me go now to the last one. Just like how I did with the other ones, the first thing that I'm going to do here, I'm going to replace negative x. If you notice, I have two variables there, so it's going to look like this. Negative x to the second minus 3 times negative x plus 4. Alright, so this is negative and this is even, so you get positive. This is negative and this is odd, so you get negative. But since you have a minus outside when you multiply, you get positive 3x, and obviously the 4 stays the same because that's the constant there. And now by looking at it, what you're going to say here, is this the original here? See, this is not the original here, so you know it's not equal to f of x. So you know it's not even. But what is the next thing that we're going to do here? We're going to factor out the negative sign. Now you do the opposite of everything you see here. So you get negative x to the second minus 3x minus 4. And once again, is this here the original? No, it's not. So it's not equal to negative f of x. So that implies that this is not odd. So in this case, if you notice, we basically try both of them. F of negative x is not equal to f of x, and f of negative x is not equal to negative f of x. Therefore, it's neither. And that's basically how you're going to set up the answer here, not equal. So I really hope that this video helped you out. Wait for the next one.